yeah, you have down the control
Control of.
of everything. Like you can just scroll through the Jamboard slides,
Which slide should I go to?
just any slide wherever you are solving.
Okay.
Okay. And the answers that we have till now, let's go ahead and put them here. So those of you who are watching, we are just working through the IOQM 2023 problems. We have Arjun Gupta with us, and earlier we had Gunjan Agarwal and Raghunath as well. We are together solving these. So these are the answers that we have so far. Don't take them for granted because they may or may not be correct. We think they are correct. That's why we put them up. But this is the thing. Okay. So this word. So I think there is a question from the from someone in the in the chat that what is the expected cutoff? Huh. This one was. What do you think, Arjun? This one was hard, right? This paper.
At least according to how the last few questions were, I think this was quite hard.
This was quite hard actually.
Even that coordinate geometry question in which we had in center, like the equations were like so big, anyone would leave it in actual paper.
Right, right. That is true. I think all the 5 pointers were quite hard. The 3 pointers and 2 pointers are more doable in that sense.
Yeah, probably.
So yeah, we are not in any hurry. We will just go through all the questions as many as we can uh, in this paper, given the amount of time we have. So some of them are really simple, not simple. I would say it's simpler than than the 5 pointers. For example, so I think these are the questions that we did already. Question number in the previous video we did these questions. So let me just go ahead and go to the
You're presenting a solution.
I'm not actually.
Oh,
I'm
so
trying. I'm trying to. Yeah, you want to present something?
yeah, I want to present 26.
26. Okay, go ahead.
Uh, so I'll just copy paste the question on page 2 and I'll just explain it once. Hmm. So in this question, the question is we have like coins of denominations 1, 2, 4, and so on. uh, 1 to 4, all the powers of 2 including 1, and what we are usually willing to do in the question is given a particular amount, say 20, or any amount we are trying to give it to, say, a shopkeeper, like you do it in your daily life. So there are a lot of ways to do it. Maybe you can give one 16 rupee coin and one 4 rupee coin. Or if you have to give 5 rupees, you can give a 2 rupee coin, another 2 rupee coin, another 1 rupee coin. The only condition imposed is that you cannot use a coin denomination more than two. For example, more than twice. For example, you cannot use three once while giving a 5 rupee coin because you have three times used this coin denomination one. So that's the only condition. And what the question is asking us is that in how many ways can we give 100? So I'll go to the next Jamboard. So essentially, for example, we can give 100 like say 64 plus 32 plus 4. We can also give it like say 64 plus 32 plus 2 plus 2. But we cannot give it like we cannot do 64 plus 32 plus 1 plus 1 plus 1. So we are asked to determine all possible ways to give. For example, even in the question itself, it's given how many ways we can make 5 and how many ways we can make 4. So the strategy to will the way we will solve this question is by recursion. So let Fn denote number of ways to form n, number of ways to form n. The question asks us to determine the value of f100. So the idea is we'll make a recursion. So our claim is that f of 2k is equal to uh, f of k plus f of k minus 1 for all k greater than equal to 2. And our second claim is that f of 2k plus 1 is equal to f of k for all k greater than equal to 1. Yeah. So the way we prove is that essentially we look at while forming n, how many coins of 1 we are using. So in case suppose we have to form 2k. So we have two choices. Either we use no we use 1 0 times 0 1, and or we use two ones. So in case we use zero ones, the rest of it has to be done with 2, 4, 8, and so on. And that's like equivalent, like forming 2k with 2, 4, 8, 16, and so on is same as forming k with 1, 2, 4, and so on. Essentially, we are multiplying everything by 2. To be more formal, I'll go on page 5 and say the problem is essentially asking us the number of ways to write n as a naught plus 2a1 plus 4a2 plus 8a3 plus so on equal, which is like summation I greater than equal to 0, summation ai times 2 to the I, where the constraint given to us is 0 less than equal to ai less than equal to 2. So for example, if we were to write n minus a naught as this thing, plus 4 a naught, that's equivalent to writing n minus a naught by 2 as this thing. And the number of ways to do this is just f of n minus a naught by 2. This is actually not so hard to see, so I won't elaborate more on this. If anyone has any doubts where I'm unclear, just please put it in the chat because I myself don't know what thing is very clear enough and what is not. So I'll again write the recursions we have. These were the two recursions we have, and the other recursion was f of 2k plus 1 is equal to f of k. Now I will just spam all these recursions and eventually get what is f of 100. So let us just spam. So what is f of 100? F of 100 is f of 50 plus f of 49, which is equal to f of 25 plus f of 24 plus f of 24. This is equal to f of 12 plus 2 f of 12 plus 2 f of 11. I don't know if there is an easier way, but this is at least fine. And this is equal to 3 f of 6 plus, I hope everything is clear. 3f of 5 plus 2f of 5. Yeah. Fibonacci numbers are popping up everywhere. I don't know what's happening. And this is equal to, yeah, so first let me write this 3f of 6 plus 5f of 5. And now how can we reduce this further? Yeah, so now what is this is 3f of 3 plus 3f of 2 plus 5f of 2. Um, am I right? Yes, I think I am right. I am right. Which is 3f of 3 plus 8f of 2. Now f of 3 is easy to compute. What is f of 3? You can write 3 as 2 and 1 only. So this is 3, and f of 2 you can either write it as 2 or you can write it as 1 1. So this is 8 into 2, which is just 3 plus 16, which is equal to 19. So our answer for question 26 is 19. Does everyone in the chat have same answer or have I messed up somewhere? I'll just once verify if I have messed up somewhere or not. Yeah, this thing is fine. Then f of 25 is this, 2f of 5. Then 3f of 5 plus 2f of 5. This is 3f of 6 plus 5f of 5. Then f of 6 is 3f of 6 plus 3f of 2 plus 5f of 2. 3f of 3 plus 8f of 2. Now f of 3 is f of 1, which is 1. And f of 2 is like f of 1 plus f of 0, which is like 2. So yeah. I think this is correct. And the answer for question number 26 is 19. Yeah.
Okay, very great, very good, very good. So we have, yeah, someone is asking this question, that question number 21 9 answer is 95. Yes, that's true. That's what we got. So all the answers that we have got so far, I have put it in the first page, and I will also put them in the chat so that, okay, this is confusing. So anyway, so this is the one. Okay. So let me try um, problem number 14. So I'm in page. Can you go to page 7, Arjun?
Yeah. I'm on
Okay.
page 7 only.
Oh, okay. Thank you. So yeah. So the question number 14 is, okay. So let me just go ahead and pick that up. Yeah. 14 is ABCD a triangle in the XY plane. So let me draw the XY plane. ABCD a triangle in the XY plane where B is at the origin. B is the point, is this particular point, and BC is produced to D such that BC is to CD is 1 is to 1. So maybe it's like this. We don't know. So ABC is like this. B is at the origin. BC is produced to D such that BC is to CD is 1 is to 1. So basically, C is the midpoint of D. CA can be produced to E. CA can be produced to E such that CA is to AE like this is again 1 is to 1. and AB can be produced to F such that AB is to BF is 1 into 3. So AB is BF is much larger. So yeah, this is BF. So that's fine. Let G be the centroid of triangle ABC. G be the centroid of triangle ABC, and K be the centroid of triangle GEF. K be the centroid of triangle GEF. So G is 32 comma 24. G is 32 comma 24. We want to find out the length of GK. So K is the origin. So I think this problem sort of invites coordinate dashing, but let me double check. So someone is saying 14th answer is 40. Okay, so maybe that's correct. I don't know. We'll see. So I mean, we could do the bashing. Like, let's say this is cx comma cy. This is ax comma ay. Then we know that is ax plus cx by 2 by 3, sorry, is 32, and ay plus cy by 3 is 624, right? Because b is the origin, so I'm just using the centroid formula that you add the coordinates and divide by 3. Now I'm just inclined to, uh, do something in this particular problem. So let's see. What else is given? So, I mean, I could do the calculation. So, for example, I could do this one as 2cx. I don't know, I don't think it's too bad, but let's see. 2cx comma 2cy. This will be the coordinate of D, right? This will be the coordinate of D, and the coordinate of A is okay. I don't think that's too bad actually. It's doable. So this is uh, ax minus cx by 2 comma, oh I see, no, this is 2ax minus cx, and 2ay minus cy. That's the coordinate of E. Because you see, if you just add 2ax minus cx with cx and divide it by 2, you should get ax. And 2ay minus cy plus cy divided by 2, you get ay. So that's fine, I guess. And the same thing works for f. So what is it given? It's given that AB is to BF is 1 is to 3. This is 1 is to 3. So yeah, I think we can do the same calculation. Uh, this is
So I
basically,
think the coordinates of V are wrong, I guess,
sorry,
because A C A is to A is two, so A is twice of AC.
sorry.
A is not the midpoint of segment EC.
It's not. Wait. what it is given. Oh, it's 1:2. Sorry. It's not right. Yeah, that's right. I didn't see that. I thought it was 1:1. Oh, I see. So this is AC is to CA is to AE is 1:2. Okay. So we can just solve this. This is pretty simple actually, because this is, if it is T1 comma T2, we can just say 1 times T1 plus 2 times Cx 3 is equal to Ax. So we get 3Ax minus 2Cx is equal to T1. So you get the same thing actually for T2. 1 times T2 plus 2 times Cy by 3 is equal to Ay. So 3Ay minus 2Cy is equals to T2. So you get the two coordinates here. 3Ay, sorry, 3Ax minus 2Cx, comma, 3Ay minus 2Cy. Okay, so the same thing works here. So let's call this J1, J2. Then you have 1 times J1 plus 3 times Ax is e by 4 equals to 0. So you have J1 equals to negative 3Ax, right? So wait, let's see. 1 times J1 plus 3 times Ax by 4 is equal to 0. So J1 equals to negative 3Ax. And this one is negative 3Ay. Okay, so now we can calculate the centroid of this one. So just add the coordinates up. So if you add them up, you will get 3. Let me make some space. So 3Ax minus 2Cx plus 2Cx minus 3Ax. Wow, is that correct? 3Ax minus 3A minus 2Cx plus 2Cx minus 3X. So by 3. So this is coming out to be 0 comma 0. The the length, the point K, the centroid, origin is coming out to be the centroid. Am I making some mistake? I don't know. Maybe. We'll see. So so GK is just 32 square plus 24 square, which is 1600. So GK is square root of 1600, that is 40. Maybe not. Maybe I'm not making a mistake because someone said it's 40. Okay. Oh, Phoenix says it's 40. So I think I'll have the answer for that.